For centuries, human craftsmanship is deeply connected with the material itself. But what if the target material itself become a virtual entity? We are no longer dealing with its physical property, but the digital body. With the assist of augmented reality, humans at the first time can interact with the digital body with a tactical interactive feedback loop to design and make. We call this type of craftsmanship augmented craftsmanship. As the initial research to decode the physical behavior, we draw the fundamental twisting and bending behavior from daily used sheet material, paper, and foam. Using computer vision and tracking technology, by attaching the marker to the end point of paper strip, we are able to capture its digital twin and store it as form data. The results are categorized by different typologies. Once the decoding is done, we programmed higher level of control, allowing a single marker to control multiple strips at once by moving the markers. Users can play with the marker in space to achieve dynamic results that is encoded from paper model. We also decoded the material property of foam as it can produce fluid curvature. Foam is more dynamic than paper and can give us more interesting results. To achieve collaborative results, we allow multiple digital bodies to be combined together for a larger piece of creation. Here, multiple people can participate in designing simply by moving the customized marker around and see how it can work with other people's creations. With augmented reality, anyone can design and make through the digital platform. Modern living in a city can be difficult at times due to stress and pollution. With the advancement of technology, people seem to be connected but rather feels isolated. So many people all over the world choose to go back to nature and start living a new way of life, the off-grid lifestyle. The government proposes reducing UK greenhouse gas emissions to almost zero by 2050 under a new plan to tackle climate change. In Three Rivers Recreation Area, there are about 500 homes there, all of which are off the grid. Living off-grid is all about living a self-sufficient green lifestyle, one not dependent on outside resources. We propose a democratized user-owned platform for building off-grid wood house communities with the help of AR. We call it LaminAR. LaminAR empowers community members to design collaboratively and fabricate complex bending wood structures with the glue lamination technique. Users can bend the wood at will through augmented reality by simple tools without using heavy machines. Living off-grid by the forest, wood is selected as the most sustainable and accessible material for house construction. The local wood manufacturer would cut the wood into quarters and slice them into 2 to 3 millimeter wood sheets for glue lamination. We measured the minimum bending radius of each type of wood, as well as its twisting ability. After a series of material testing and comparison, we finally selected oak as the primary material due to its straight grain and tolerance to bend and twist. LaminAR uses the user's current location to search the nearby forest. Users can also locate communities from recommendations or through the interactive map. We encourage close friends or families to create an intimate community. One of the members will be the host of the community and invite other members to join. LaminAR will collect all community members' preferences such as bedroom number, indoor area, etc. Once the user preference is set, the system would match users with a list of recommended sites. Members can decide the site and share it with other members. Any community member can host an AR design session room and invite other members to join. In the AR table mode, LaminAR utilized the scanned litter data in the backend to recreate the virtual site, allowing all the users to preview the site without going there. LaminAR encoded the foam twisting and bending behavior as the major design interaction. By default, we provide a large virtual object library to start with. With our marker system, users can customize the default digital object through the quick menu and adjust it to the desired form. In the collaborative design room, not only you can see your own creation, but also others' work in relation to yours. To achieve the optimum results, community members need to collaborate with each other to determine the relationship between the buildings and the surrounding environment. LaminAR provides users with a variety of spatial volume catalogs. The intertwined volume enables dynamic living space and fluid circulation. Private space will be located at the center of the volume and leaving the end for the shared space. Once the general massing and spatial volume are set, LaminAR will extract the outline edges from the volume as the main structural frame. We have designed the node that is attached to the main frame. Users can load the node from our node library. Each node has one primary layer attached to the main frame, and the rest can be twisted and bent at different angles. After the nodes are selected, users can place the node in AR simply by scanning the marker in the space. They can also choose to generate the nodes on top of the main structure automatically. We have explored different ways connecting wood strips in achieving the balance between structural stability and curvature. The connection between nodes would be bridged once the nodes are placed. The secondary structure would be then generated between the main structure. Double-layered panel will be placed on top of the structural frame for enclosure and waterproof. LaminAR is integrated with project management features and can help users to track the progress from design to build. Once the design is approved by all the community members, users can order material to be picked up with the necessary tools. To fabricate the bending wood structure, we have designed formwork specifically for bending large pieces at the balance between cost and flexibility. The formwork is composed of the base stand, central pole, and branches for clamping. Each component is free to be rotated and adjusted at different heights. The formwork provides large freedom of customization to users in order to adapt to different situations. To achieve maximum efficiency of fabrication and assembly, users can host AR build session room and invite all members to join. Users can select the structure to be fabricated from the 3D blueprint in AR and request material from the material team. Community members can then bend and twist the wood following the hologram guide and request formwork to be placed at the exact location to anchor the wood piece. Once the primary structure is completed, the assembly team will be notified to install pieces together following the hologram 3D guide without need of using 2D specification.